Hello, everyone. I hope you're having a good day. Let's wait maybe a minute or two, giving the others the chance to join, and then we can start this session. Asim and Beck will be presenting today around containerization. So like I said, thank you for joining, guys, today. Let's give like another minute so the rest can join, and then we'll start the presentation, the workshop. Thank you. Asim, I allowed screen sharing, so you can share your screen.
Yeah, sure. I'll just begin. So I hope you guys can hear me well. Bex, if you could just give me a thumbs up. Um, perfect. Sounds good. So hello everyone. Welcome to our webinar on containerization in MLOps. Today we will be talking about the containerization, what is Docker architecture, how we work on machine learning models and operations. So yeah, I think I can share it now. Perfect. So you guys can see my screen. Okay, perfect.
Yeah, all good,
Sounds
Asim. We can see your screen.
perfect. Since you guys know, today we have our webinar on containerization of machine learning applications, and this will be presented by me and Bex by Rocket Science and Women in AI. So I'll just give a quick introduction about myself. I'm working with Rocket Science as a machine learning engineer and as an MLOps developer. And today I will be talking about some of the best practices that we do follow in Rocket Science to work in machine learning models, and how we do the complete process of the model development from scratch, from building to designing to the development, and then finally putting the model into the production, and then how we do the model serving and like all that stuff. So the agenda for today's presentation is going to be containerization. And within containerization, one of the state-of-the-art tools, which is basically Docker. So Bex will talk about what is image versus container, and then where Docker lies in software development lifecycle, what is the architecture of Docker, what is Docker repository, and then where Docker lies in MLOps. We will talk about MLOps as well, but the main focus is going to be on the containerization, because we really want to see how the machine learning model actually serves better when it is containerized and when it is in that particular MLOps environment. And last but not least, we will talk about the orchestration environment, and we will have a small demo in which we will actually build one machine learning model, and we will containerize it. We will push it to Docker Hub, which is basically Docker repository. And from there, we will do the model serving. We'll pull the model, and then we will see how that works. And by the end of today's session, these are some of the objectives that we will achieve. So we will come to know what is containerization, what is MLOps, how Docker is used in CI/CD pipelines. Today we will see how a machine learning model is actually Dockerized. So we will make a container out of our ML model, and then we'll push it to Docker registry, as I mentioned, and then Becks will pull that model on her end, and she will show that how in just one line of code you can set up a complete ML model, I would say infrastructure on your system without having the need of installing any libraries, any softwares, any other tools for that particular application to run. And then how containers actually gave a rise to a microservices architecture. So yeah, so these are actually some of the questions and some of the key objectives that we will be able to answer by the end of today's session. And from here, I think Bex, you can begin.
Yeah, thank you, Asim. If you give me just 2 seconds. So thank you. I'm sorry, Bex. I got you on this one. Actually, I want to thank first of all, Women in AI. And I want to thank Bex as well for her time. Rocket Science is basically, I can give a quick intro about the company. So it's basically a company specialized in MLOps. We help companies basically create a machine learning operation environment. This is not our first webinar. We did a couple of others around tool comparison, and we host almost every 2 months webinars around this specific subject. I think probably the next one will be around CI/CD in maybe end of November. So I'll let you continue, and I'm sorry for this little interruption. Thanks.
That's all good. Thanks for that. Hi, I'm Becks. I'm a mentor at Women in AI, but I'm also an AI full stack at a company called Rogo, which is one of the incubations of a bigger company called Alicorn North. So excited to be here. Hope you all learn some super exciting things about MLOps and Docker. So yeah, take it away. So containerization basically is a really nice way of packaging applications with everything they need, including dependencies and all of the different environment configuration that's required. So you can see there's a little picture on the side here. So the container engine, which is, something like Docker, which can build the pieces that you need, sits on top of the operating system and basically virtualizes that. And so you can see here the little, app 123, which is containerized with all the pieces that it needs to run just by itself. So it's a very portable way of setting things up, easily shared and moved around, as you'll see later in our demo. And yeah, it's a nice way of isolating environments, which then makes the deployment process much more efficient. And as I said, they can run as standalone entities without having to set up on the actual device that you're running on, which means there's some low coupling with software components that are otherwise highly dependent. Next slide. Cool. So some of you might be thinking, oh yeah, but there's a thing, virtual machines, why don't we use those anymore? And so we put together just a little comparison of virtual machines versus containers. So previously everything was done with virtual machines, but more recently we've moved to containerization. So the difference there is that with virtual machines, they emulate everything, including the hardware. Whereas containers virtualize just the code and the packages and the operating system. So you might have a virtual machine that emulates a full Windows setup or a full Mac setup, whereas the containers is just the operating system and the code, where instead of the hardware aspects as well. Virtual machines are platform independent, whereas the containers are platform dependent, just because they don't emulate the hardware. So they do rely to some extent on what's happening sort of under the hood in terms of accessing hardware. VMs typically take up a lot of system resources because they're doing that kind of hardware abstraction as well, whereas containers require less memory and resources. And obviously VMs are slower and less flexible to deploy because there's a lot of setup involved there, and they're less portable, whereas containers are faster and more portable. So you might be asking, okay, cool. So how do we do this containerization thing? So here we're introducing Docker. So Docker is a nice tool to containerize software applications. At a high level, it's like a Linux utility that can efficiently create, ship, and run containers. It's mostly used in machine learning operations to deploy models into production and make retraining, reusing, and redesigning different models a lot easier than it has previously been. It also solves the problem of environment inconsistency, because you basically bundle up everything that you might need to, train or use a machine learning model in production, all in the same kind of container, so that you don't have to worry about, someone developed it in some way, and then when you deploy it, it has different things that it requires that are not installed. So yeah, Docker help solve those issues. It also makes scaling the number of things that you have running a lot easier as well, because it's just a container, so you can spin up a bunch of different ones, or scale down if you don't have as much need for all those containers. And it's typically used at the deployment stage of the software development lifecycle, but also being used more and more in development as well, to make sure that when people are building and training models, doing data pipelines, that kind of thing, that they're starting to build from the same environment that they'll eventually deploy in. And so you might be asking, that's cool, but why Docker specifically? And it's really a question of market share there. So it has a massive, market share of about 98% almost. So it's a lot more popular than some of the other options out there. So it's often, best to use sort of what everyone else is using. Yep. And so there are some pros and cons, obviously, to using any tool. And some of the ones with Docker, the pros are that typically what you build is quite small, which is convenient. You don't have to, you're not building these huge images and containers that you need to move around. It also facilitates rapid delivery and reduces the time to deploy, because it's, quick and easy to use. And obviously is, building these small containers that are then easy to deploy. Offers simplified maintenance and the ability to run, I put in brackets, almost anywhere. And that's obviously related to one of the cons, which is like, it's not cross-platform compatible out of the box. So there's a few, like typically it runs on Linux, but you can also run it on Windows and Mac, but there are some extra tools that you would use to get that to work. One of the other cons is persistent data storage is a little more complicated. So you can either build things into the image, but typically you will mount like where your storage will be inside the container. And so just, figuring out how to do that and where to put things and how to connect it all can be a little more complicated. It doesn't have a GUI, like a graphical user interface. So it does require people to use command line interface to actually interact with it, which can be a con for some people who are, less technically inclined. And obviously not all applications benefit from containers.
Perfect. So I think from here, I can continue, and let's talk about where do containers live. So as you guys know, I mentioned about the containerization. Beck, if you can give me the control back, I think you have it. Okay, perfect. Okay, sounds good. So where do containers live? So as I mentioned, we will be looking into the Docker Hub. It's basically that one particular place where we actually keep all of our containers. So they have their own public repository, you can say, or anywhere, like even for a company or even in Google, like if you're using GCP, so they have like, they have their own repository, AWS has their own repository. So this is that one particular place where you containerize your machine learning model and you actually push it to that particular place. For me today, I'll be using Docker Hub because that's actually where we have all of our applications, like all of like Python and Redis and like, anything that you want to run on your system. You don't have to just go and like, do all the requirement stuff and everything. You just pull it from the Docker Hub and you will be able to run it on your system without like, worrying about whether it will work or not, or it will have some problem with like, some system dependency and all that stuff. So containers live in a repository, and many repositories make up a registry. Many companies have their own repositories, and then these repositories can be private or public, like, based on the access that you give them. The most commonly used, like, registry for Docker or the containers is basically Docker Hub, where we have the access, like, options. We can have private registries and we can have public ones. And then a container can be run in few steps by simply pulling it from a repository and can be controlled on a command line. So today you guys will see that Becks will actually pull one container on her end with just one line of code from Docker Hub. But obviously she just needs that one link, and she will be able to run a complete machine learning model on her end, like the complete front end, the complete back end, the database. She does not have to do anything. She doesn't have to pull like so many images from that one hub. She just have to like, pull that one application, like that one container, and she will be able to run that entire application on her end. So now we have this thing, which is where is Docker in software development lifecycle? So as Becks already mentioned, we when we are developing an application, so we make containers of those small units so that we can reuse them, we package them with all the dependencies, because in one machine learning, like, I'm talking about the one complete project, there might be like, a scenario where you are using some of the tools require Python 2.7 and others require 3.6 and all that stuff. So what you do is you make containers out of it, and then you actually like, use them while you're developing your machine learning project or your software. But most commonly it is used in the deployment phase. So once you develop your like, your machine learning model, you use containers specifically when you want to deploy your application. So you don't want to have like, in the deployment, we don't want to worry about, okay, what are the requirements? What are some libraries that this application or this model should be using? What you do is you just wrap up everything in that one particular container and you deploy it. And the deployment, I mean, is you push that image to a registry which is basically Docker Hub or any of the registries, and then from there onwards all the pull commands are actually triggered, and like, some other stuff happens. So it takes in the developed application the Docker, and it wraps it up with all the required packages into one single deployable unit. And then the deployed Docker container is then moved into testing and product release. And what happens is that once we deploy that machine learning model, and then we have to test that particular unit. So whenever we are developing any software component, we have to do continuous testing for that as well, so that there are no bugs in our application, no bugs in our code. So if we deploy them, we don't have to, the testing team does not have to worry about like, taking care of the environment, taking care of the infrastructure, because within that one particular Docker container, everything lies. So they just have to pull it from the deployment. They don't have to go back to the development team or to the designing team to actually give us, okay, what libraries are required for me to test this application on my end and all that stuff. So deployment helps in, like, in pretty much so many ways, and that's why it's specifically used for like, when we are actually deploying our machine learning model into production. So now let's talk about the Docker architecture. So as I mentioned, we have a registry, which is basically, it could be Docker Hub, or it could be any of the registries. And we have, like, all of these are basically images, the one you see on the extreme right. So what happens is that you are a client, like you on your machine, you are a client. And what you do is, in order for you to run that one particular container on your system, you use various commands. And today I will be using all of these commands. I'll be using Docker build, I'll be using Docker run, and then actually Becks will actually pull that one deployed machine learning model that I'll push to Docker registry. So you have this Docker host, which is basically that one particular application. That's the only thing that you need to install on your systems. What you do is you just pull the image from that one particular registry, and it resides in your, you can say, in images, folder or whatever within your system. And now what you do is you make container out of that one particular image, and then you are able to use that ML model or any, it could be Redis, it could be anything on your system. So that's actually the architecture of Docker. So we are just able to use any software component from Docker Hub with few lines of code, and we have that software working on our end. So yeah, Becks.
Cool. So within Docker and within that architecture, you will have seen mention of images and containers. So those are two extremely important concepts within Docker. Yes, sorry, just looking at the comment. Yeah, so the difference between those two, because sometimes people use them interchangeably, but they're not exactly the same thing. So the images are typically a snapshot of the actual environment, sort of like a blueprint of what the container will actually run, whereas the container is sort of the thing around it that actually runs the thing. So it takes the image and runs it. And so images are more like a read-only template of instructions to create the container. You can base them off other images, and there's a specific command which you use to to build those. So we saw in the previous slide, it's Docker build, whereas for containers, you use something like Docker to run to actually, run a container with a particular image that you've built. And it's important to know the difference between those two, because often different systems will require you to input things in different ways. So systems like Heroku expect sort of image-based, expect images or to use images, whereas things like Pivotal Cloud Foundry will expect you to give it a container. And so knowing the difference between those two and how to, give them one or the other, and make and use one or the other is super important within Docker. Next slide. So how do we make Docker images? We do it using a Docker file. So it's basically a YAML document. So it looks a bit like a text document with a specific format and the YAML extension. And inside there, it contains all the commands that you would typically call on the command line to actually assemble the image that you want to build, with all the dependencies and the code and the environment variable setup and everything that you would need to make that snapshot. And so Asim will show us a example of that in the demo. And then using Docker build will allow you to actually execute and build what was in that Docker file to make your Docker image. And then, yeah, we'll run through the commands in the demo to show like what is actually involved in writing a Docker file, but then also taking it and building an image from it. Cool. So there's another thing called Docker Cloud, which is a service provided by Docker, which you can carry out the following operations. So there's nodes. You can connect to Docker Cloud. Connect Docker Cloud to your existing cloud providers like Azure and AWS to spin up different containers. There's Cloud Repository, which is a nice place. A place where you can store your own repositories. They have continuous integration where you can connect with GitHub and build a continuous integration pipeline. and application deployment to deploy and scale infrastructure and containers, as well as continuous deployment, where you can automate your deployments of different containers.
Perfect. So I think now we can talk about MLOps and why we actually do this containerization. So what's the need of actually Docker and why we containerize our application and why we need Docker Hub and all of that stuff. And the reason behind all of this is MLOps. So traditionally, you guys would have seen that we already have DevOps. So once we have not a machine learning model, we have any other software, and we want to put it into production, or we want to deploy it into the production environment. So we already have DevOps that exists. And then we make use of it to automate the process and everything. But the reason why we use MLOps is the way a machine learning model is developed, or a machine learning software, I would say, is developed, is different than a way a normal or a traditional software is developed. And we will go into the details of what's the difference between them in the next slides. But I'll just talk about that. In order for us to automate the complete process from data gathering to model development to model deployment, and then to track the model, to version the model, and then to scale the model, actually to reproduce the model, and to do all of the to look if the model is working fine, if there is a problem in the model while the model is in the production environment or while the model is deployed. So there has to be an automation of retraining. Like, we shouldn't be sitting there looking at whether the model is working fine or not. This MLOps is looking and tracking the model's performance, because with time, the model decays, the data changes, the environment changes. And so for that, in order to keep the model up to date, we have to retrain the model. So there has to be this one complete cycle. And this entire cycle, where we have all of these operations taking place in parallel, is known as MLOps. So now I think I can just read some of the points from the slide. So the use of machine learning models by DevOps teams is specifically known as MLOps. And again, it seeks to add the discipline to the development and the deployment of ML models. MLOps is based on DevOps principles and practices. So for instance, continuous integration. So if you are working on a huge software project or a machine learning project, and then you have various components coming in, and then there is a dependency between those components. And if you want to do a continuous integration of those software units or those machine learning models, so you need that one set of principles or set of softwares which takes care of that entire cycle for you. And that's basically where you look into continuous integration, and then the continuous delivery of those softwares into the production, and then finally they get deployed. So MLOps applies these principles to the machine learning process with the goal of faster experimentation and more robust development of models. I'll just share something very quick with you guys. So a couple of days ago, I was just looking at why we need MLOps. Like, if we already have some of the softwares which are like MLE, right? Like, before MLOps, we had MLE. So that would also look into building the model, to like designing the model, building the model, and then pushing the model to the production. But I was just reading somewhere that before MLOps, if a change occurs in the production, if there is a decay in the model, if the model is not working fine, like there is some problem in the model, right? So we have to retrain the model. We have to see whether there is a problem in the code, whether there is a problem in the data, whether there is a problem in the model, or what has happened that our model is not working the same way as probably it was working since last 6 months. So in order to track that one bug in your application, it would take somewhere around a day or two before MLOps. But now with MLOps, it takes around 8 minutes to track that bug automatically. Like you don't even have to go in and find out like if things are fine and all that. Within 8 minutes, this automation itself is capable of finding that bug and then retraining that model, looking at the data again. Obviously if it needs more data, then we have to actually look into some other stuff for that. That's actually another thing, because obviously if we don't have the data and something happened on the data, and then that's actually about the architecture side of the story and not something related to the model development. But the reason being, just to mention all of these points, is that this MLOps is so strong and so robust that imagine comparing 2 days with 8 minutes. It's a huge difference, and that's what we are able to achieve with the help of MLOps. So now let's talk about this. So there is this one principle, which is changing anything changes everything. And that's basically about the MLOps. So in MLOps, what we do is if there is a change in anything, it changes everything that we have in our application. So in our deployed application, actually. So for instance, as I said, the way a machine learning software is developed is way more different than a way a normal or traditional software is developed. So we have data, we have model, and we have code in our machine learning projects. And the change or the trigger to build the model or the trigger to do anything within that project or within that software can be due to data. It could be a data trigger, model trigger, or code trigger. So if there is a change in the data, like if a new data comes in, definitely you will have to change your model. If there is change in the model, because with time you get to know that you built your model looking at some specific type of data, but now you have new type of data coming in. So now what you have to do is you also have to change your algorithm. Initially you were using some ensemble learning and stuff like that, but now probably you have to go for some regression or for some deep learning kind of stuff. So you have to change your algorithm, and in order to change your algorithm, you have to change the code. So all of these things. So if there is a change in one thing, it changes everything. So that's why we need this one robust architecture that takes care for everything that happens within that one particular pipeline of the development of our machine learning model, from design till production. So here we have a small here we have a small life cycle of machine learning operations, or MLOps. So we can see that how it actually works. So okay, so I think we can start from if you see from the top left, we have this from the development side. If we see, so anything that we have, any data that we have to use to build the model, we make features out of it. And there is this one feature store concept. So what we do is, again, I wouldn't get into the details of what feature store is, but for now you can say that this is a repository for of inputs that are used by your machine learning model to be trained. So you use those features to actually do some data analysis. You run some data science DS experiments, and then you go and you build your you do some model analysis, like you test various models, and then you push it to a source repository. So from there onwards, you have like CI/CD, like continuous integration, continuous delivery. So you build your application, you test, you package your application, and you deploy it. So here you can say that we are using containerization in this process. So you pick up that one particular model, which is being built or trained on those features. And what you do is you pass it to data engineering. So data engineering is basically that one pipeline again, like, it puts the data in the right format, and it sees if there are some other input pipelines into my ML model. And then you do the model engineering, you have this metadata store. So you actually version your machine learning model, it goes into the registry, and then there is this another stage, which is basically the model serving. And then finally, you have the model prediction service. So at this point, you have the performance of the machine learning model, of the deployed machine learning model being tracked or being monitored. You really want to see how your model is working. If it's working fine, that's okay. But if there is some problem in your model, for instance, you can say that keep on coming up with the predictions and just trigger me once my model has an accuracy of less than, for instance, 70%. So that's basically performance monitoring. But a trigger or an alert would happen if if there is if the performance of the model is not good. And again, you can give a timeline that if for the last 24 hours, if for these many number of times the test has happened, out of this, if 50% of the times or maybe 30% of the times, if the test does not meet our expectations of the model performance. So what you do is just go back, look at the data engineering side, look at if the data is being supplied to the model properly, if there is some problem, and then finally go back and retrain the model. So this entire infrastructure that we have built, from data cleaning to data to feature feature store to model analysis and all that stuff, all of this will happen again. And then finally we will have our ML prediction service take place again, and then we will see that our performance is now better. And all of this is an automated process, so we don't have to go in and do anything on our end. All of this takes place because we have written the test cases and we have all the code base ready. So what we do is we just have to be able to know exactly what we need to write within that MLOps entire architecture for us to have our machine learning model at scale. So it's being served to the end user without any delay and stuff like that. So that was our life cycle of MLOps. And now what we can do is we can talk about some of the components of machine learning operations. And Becks, you can begin.
Yeah, so just to recap on a lot of the points that Asim just covered, some of the components of MLOps are exploratory data analysis and making that process automated, automating pipelines for data preparation and feature engineering. So if you have raw data coming in, extracting features that are useful, or transforming that data so that it's usable for a machine learning pipeline, either for training or for inference. Other processes like model training and tuning, review and governance, which as Asim mentioned, is once you have a new model, testing it against the one that's currently deployed, making sure that it's not regressing if you were to put it into production. Model inference and serving. So automatically, once you've checked that your new model is good, to deploy that in production and run that for inference. Monitoring to make sure that, as the model is making different predictions, that it's not getting worse over time, or having any other issues. And then also automated model retraining. So maybe after you collect a bunch of data and a bunch of predictions, you find actually you need to retrain because the data distribution may have shifted or something like that. With MLOps, you can, set up a process to automatically go back and train the models that you have with the new data that you have. So the need for MLOps. So basically any organizations that are building machine learning models and incorporating them into their product offerings will need MLOps. And much like DevOps before it, it's becoming a lot more popular because of the increased awareness that model development and deployment are intrinsically linked. So you can't just develop a model and then expect that things will be completely different once you actually put it into production. So having things like, unified experiment management, automated training and comparison, automated deployment, and automated monitoring are all critical components of the ML product lifecycle, and that's what MLOps is there for. So anyone doing any of those definitely needs MLOps. And obviously, because we're here, containerization is one very important step in MLOps. And so with that, Asim, take it away with the demo.
Perfect. So from here onwards, I will just go ahead and we will have a small demo on the containerization. Let me share my screen, and then from there we can begin. So I will stop it here, and I think we can take it out. Perfect. So I hope you guys can see my screen. Becks, can I get a good? Okay, perfect. Perfect. Thank you. So now what we'll do is we will actually build one machine learning model, one small ML model. And what we'll do is we will Dockerize that ML model. We will put it into the we will push it in or to actually Docker Hub, which is basically that one registry where we have all of our containers. And then we will pull it like any one of you. I will give you the access, but essentially Becks will actually be able to pull it on her end, and will show you that how my developed machine learning model. I'm using Windows, for instance. Becks is using Mac. So she doesn't have to worry about any of the system dependencies or any OS dependencies and all that. So with that, I'll just show you this one small model. So it's basically a very basic sentiment analysis model. And then I have this small app.py. So it's basically a Flask application for the front end, where what happens is that you just come and you write any text message, and you can predict whether that's positive or negative, and then it will show you the sentiment about that particular sentence. That is something that you most of you already know. What we are interested in talking about is how we actually Dockerize that application. So how we actually make a container out of that application. So what we do is, also one thing to mention, we have this one requirements file. So anything that is being used by this particular Python application to actually to be built is NumPy, Pandas, and sklearn is actually written in this one requirements file. So you have to actually write it, and also if you have to actually train the model, once you pull the model and you want to be able to give the access to the person who's pulling your model to retrain your model, so you can also give the data set within that one particular repository. So with that, I will just proceed. So we have app.py, we have the train, and then this sentiment is completely optional, but if you want to keep it, that's up to you. And then the templates, which is basically our index files, and then model is definitely required because it contains your deployed model. But this is something that we specifically write, and just these 6 commands, you just need this to actually Dockerize your complete application. So what is that? I will just go through them. So it's basically a layered architecture. So everything is a layer. So the first thing that you do is right now, like for instance, just consider that I don't have access to any of these things. I don't have access to app requirements, anything. The only thing I have access to this, and my application is completely blank, right? Like I don't have Python on my system. I don't have anything. So how am I able to actually run that Flask application? So the first thing that you have to do is, in order for you to run any Python application, you have to run Python on your system, right? So this from Python, okay. So this is also an image, guys. This Python colon 3.8 string buster. This is also a container. So just image, sorry, just to keep in mind. So when you run this Docker container, this Docker image or this Docker file is itself containing these Docker images. And this is basically when you run it, so it turns into a container. So the first thing that you do on your host system is to actually install Python. So you say that the OS or or the application that will be used to run this code or this model is going to be Python. Okay. The second thing that you do is within your container, you mention that what is going to be my working directory. So you create a working directory and you name it as app. The third thing that you do is you say copy everything, which is this one dot, and you save and paste it inside this app. So this app is basically what you have built here. And then by copy, what it does is it copy model, templates, app, requirements, sentiment, anything and everything that you have here. It copies everything into that one folder. And then since you copied everything into the app, so now your app has this requirements.txt file. And now you tell it, you tell your container to run this command, which is basically pip install and requirements.txt. So it actually installs all of those, libraries and all those tools on your container. And since it's a Flask application, so you have to give it some code. So you are exposing it at 5,000. So what happens is that if someone is using your application, so what they can do is they can use this 5,000 code to be able to run your application on their end. And finally, once all of this is done, now you have to run this app.py because this is that one final call to your app to run it, and then from here it actually runs this host your application web application. So you just say okay, write Python 3 and then app.py, and then it gives a start to your your application. So this Docker file is actually containing just these 6 commands, and now what we'll do is we will go ahead and we will actually containerize that application. But before I proceed, I just want to show you guys something. So you should have an account on Docker, because if you don't have an account on Docker Hub, if you don't have an account on Docker Hub, you will not be able to actually push a Docker Docker image to this registry. So you have to create an account. So my account username is my first name and last name. So it's Asim Sultan 2. And then what I have done is, just for the demo purpose, I have created this one repository within my account, which is basically Docker demo. And I have already pushed one image of this particular application, which is V1. But I'll just show you guys here how how I did all of this. So I will let me just see if we have some thing running. Yes, we have. So I will just kill the initial container, and perfect. So Becks, you guys can see the terminal, right? Okay, perfect. So now you guys can see that all of this application that we have here is basically I am in this path. And now since I already mentioned to you guys that I have built an image and I have pushed it. So if I say Docker images, So it shows me that, like, you have these images, right? You have app version 2, a tag is basically the version, and then you have another one, which is basically Asim Sultan 2 and Docker demo v1. But I'll just tell you guys that for now, I'll just skip it because like right now you guys are like completely beginners to Docker, and you have to containerize, or you have to make a container out of that one particular application. So you simply do it like this. You just write Docker, you build it, you give it a tag, and then you write what you want to name your application as. So for instance, you want to say my app, and then you give it a tag, which is basically you say v3, or you can say v1.0, and then the final thing is what files you want to be able to use and push into that one particular image. So if you say press this, it takes all the files that you have within this particular folder. Like you can see here, it's this containerized web app, and then you can just press enter. So, okay, I don't know why it's perfect. So now it's building this Docker image for for that particular application. But since yeah, I think it will take place. It's just going to take a couple of seconds, so you can see how it's actually taking all these files and all the commands that we have, and it's actually making a container out of it. So I think what we can do is I can open up another command, and I think it's okay, perfect. So I will just clear the screen, and now if I see my images, so I have this one image, which is basically my app, and then that's basically v1.0. So now this is basically your application, and now what you do is you want to run it on your system first, and you want to see whether that works or not. So the only thing that you do is you just write Docker run, and then this thing you also have to you have to take into account is that you map your port number. So you had 5,000, but what port you wanna expose it to. So I already had 5,000, and I think I'll map it to 5,002, and then I will give the name of my application. But I think I forgot. I think let me just do it again. So that was Docker run, and I will map my port number, and that was my app, and then that's v1.0. So that will run the application, and that is basically on this IP, which is 127. So let me run this application then. Yeah, so you can see here that now I have Dockerized all this application, and now I can just write anything. For instance, it's a nice weather. So, it will tell me what's the sentiment of this particular, of this sentence. So now, since I have to see if I have any of the containers running. So I'm creating a new terminal, and I want to see if I have some containers working. So I have this container, which is basically the one that I just created, and this is my app, and the version is v1.0. So let me kill this container, and I'll just copy the container ID here, and perfect. So now we will see that we don't have anything running. And finally, what I have to do now is I have to push it here to Docker Hub, so that any one of you who wants to use this application, you can just write Docker pull and the name of the application, and you will be able to access it on your end. So, but before pushing it to Docker Hub, I will have to tag it, because tagging is required for your images to be pushed. So I have these images, and for instance, I want to push this one, which is basically my app. So I can say Docker tag, and I'll initially write my own application, which is my app, and the tag is v1.0, and what tag I want to give it to. So if you come here, Docker Hub actually tells you that how are you going to push the repository or push the image to the Docker Hub. So what you can do is you can simply copy it from here. Actually, I wrote it here already, so I think this is basically your source image, and what is going to be your destination, image, like what name you actually want to give it to. So for instance, I'm going to say it has to be pushed to Asim Sultan 2, which is basically the user, and within that, what is going to be the version. So for instance, I can say v3. So take this my app v1.0 and change it to this Asim Sultan 2 Docker demo and then v3. So when I do this and I press enter, okay. So, and now if I look at my images, so I have this image, which is basically this image. And now, since I have just v1 here. So what I'll do is I'll push it to the Docker Hub, and it's just one command, which is basically Docker push. And I'll just write the name of my image, which is Docker demo, and then I have v3. So when I run it, so it actually is pushing that container to my Docker Hub. And now once it's completely pushed, you guys will be able to see that container on my account. So I think from here onwards now, Becks is going to take the control. So Becks, I'll allow you to share your screen. And from there onwards, she will mention that how she just has Docker installed on her system, and she's just going to write Docker pull and this image, and she will be able to run this complete application on her end without installing Python or without installing any other library. So you see here, I have this v3, and this is something that I just pushed to my Docker Hub. So from here, what I'll just do is I'll stop sharing my screen, and Bex, you can take the control.
Yep, sure thing. Awesome demo.
Thank you.
So I'm using a little thing called Docker Playground. Let me know if that's big enough. Oops, hold on. My God. This guy. Cool. Yes, so Docker Playground, so basically a nice way to interact with Docker if you don't want to set everything up locally. So as Asim said, it's very easy to now just pull that image that he's created and run it within either this environment or your local environment. So just simple as Docker pull and demo, and we said v3. So it's as easy as that. As long as you know what the image name and the version tag is that you want, you can just pull it as long as you're logged in. And so that'll pull that down. Wait a couple of seconds for that to happen. And voila, and then I can also do Docker run, expose the right port. And cool, so now it's running here, and we have this nice thing that will let us just open that port and have a look at the app. So let me know if you can see that.
Yeah.
And voila. And that's it.
Great. And Bex, if you can just send this link, the play with the Docker, in the chat section. So they can just pull it on their end, and they're able to play with the application, and they'll also get to know that there is this one tool. So you guys don't even have to install Docker, Docker on your system. If you have this URL, you can just go and play with any of the Docker images, And yeah, you're able to run any application without even installing anything on your system. So that was our webinar, guys, today on the containerization in MLOps. And yeah, I think now we can go ahead and we can proceed with if you guys have any questions.
Yeah, thank you, Asim, thank you, Bex. This is very fruitful and a great presentation. I hope all of you enjoyed the call. Like Asim said, if there are questions or so, you can reach out. We'll do as well a follow-up by email, sending you a link because we have a Slack channel for our community. So you can join the community and potentially ask question there and everything. The webinar is recorded. It will be on YouTube and it will be shared through our Slack channel, but as well on LinkedIn. I think there are some questions. Any tips on compression tools and approach? I might have missed something, but what does Rajesh mean by compression tool here, Asim?
I'm sorry.
The question is around the compression tools. If you read, please, the discussion.
Okay.
You want to
Okay.
answer this one?
Any tips on compression tools? So by compression, you mean all the files that we use to containerize the application. Is that what you mean by compression, Rajesh? If you can add some more detail, I think we'll be able to answer your question. Okay, perfect. So any tips on compression? I think the best tip I can give you on compression is, and this is something that I specifically myself experienced, yesterday when I was working on that, and I had some other files, like for instance, this data file. You don't need to keep the data file within your folder when you're compressing. So remove all those files, all the unnecessary files that you don't want your container to have. Try to come up with the lightest version of any software. So for instance, when I was creating this Docker file, so from was basically that one OS that I was using to run my application on. So just go ahead and use the one that is the most light version of the Python. And in the same way, as I said, try to not keep any data files, any other files within your application when you're containerizing it, because then it takes a lot of time, for you to pull. And then, that's another, it will consume a lot of resources. So just keeping the application, like the logic file, the model file, and the requirements file is more than enough for you to containerize your application. So I think that's the best tip that I can give you on the compression, Rajesh.
And
I hope this answered the question.
just to add to that, depending on what kind of ML you're doing, some of the models themselves are actually humongous. So a lot of the image processing ones are massive, and you wouldn't put them in a Docker container either. You'd put them in a model repository and then connect your Docker container to that, or connect your code so that you can fetch that model when you need it, instead of actually building it inside the thing. And then the other thing you can do, because typically if you have to build a really big image, and you can't compress it because you have things like TensorFlow or PyTorch, which are usually 4 gig or 2 gig each, you build a base image. So then at least if you're building other images off that, you don't have to wait for the whole thing to build every time. And that, it's not technically compression, but it'll speed up how quickly you can build stuff.
I think it remembers me of some projects where you see Hugging Face or BERT model, and then the model is just huge in terms of size, because that's the problem with modern NLP, is due to the amount of data at the end used, the model end up being very large, and that can cause problems when you want to containerize it. You end up with very large images. So yeah, pretty interesting. Good. What is the recommendation approach to scan Docker images against vulns? So I think he meant what the
vulnerabilities.
Yeah, vulnerabilities.
I think, yeah, Mohammed, you can proceed.
No, go ahead, go ahead.
Okay, so now I think like even the Docker Hub itself has become like, okay, are you talking about pushing the Docker images? I think you're talking about the pulling, because when you're pushing the Docker images, so you get a message stating that some of this, because I got it myself, that like, some of your maybe the confidential information or something is it can be exposed to public IP and like, on public IP and stuff like that. But if you're talking about pulling, so
I think, for example, when you get an image from Docker Hub, I would say the first advice is look at the source. If it's certified by Docker Hub, it's probably a legit image. If it's just like a random image that actually one person has been put in like a long time ago, not that much reliable. So especially if you work in companies environment, you have to be very cautious on the type of things you do and you get from public like places, marketplaces like Docker Hub, for example.
And also, I'm just looking at this vulnerability scanning for Docker local images. So I can share with you guys the link in the chat section. So here are some of the commands that you can run. For instance, Docker scan, and then you can write the name of the image, and it will it's actually gonna scan it for vulnerabilities within your Docker images that you pull from the Docker Hub. So let me share the link with you guys here. And I think it will be, yeah, it's going to be good resource.
Okay, that's cool. I didn't know about this one. Docker scan.
Yeah.
I think there were another question. What should be the measures be taken when we would want to deploy container in a third-party cloud service, like Cloud Run, I suppose, on Google, and I know Amazon have the same, AWS have the same. Is our IP exposed? Well, that would depend how you exposed your app from those services at the end of the day. You can obviously secure it. I mean, any tips on the security aspect is don't forget like open port, because open port are just the first thing, like someone wanna potentially with like bad intentions, the first thing you do, you try the different ports to find an open one that is not secured. So the most important thing I would say is just like follow that logic and make sure your application is compliant, because if you work for a company, which is probably the case, you want to make sure that you're on exposed public IPs, because some companies, they don't allow public IPs and so on. I don't know if Asim or maybe Becks have other advices or other tips on that. Or maybe Eric. Eric is on the call. He can definitely be of help.
Yeah, Eric is quite, let's say what Eric has to say.
I want our infra expert. Where is our infra expert? There you go.
I'm here. So hi. So regarding these measures, it depends on the requirements you've been given by the people that need the application deployed. So the first thing the first thing that needs to be done is regarding to the context again. If it's an application that needs to stay internal, it all needs to be on a net. I mean, the application needs to be deployed, and the containers also have to be deployed on a private network, so no exposition to the outside. Second thing, what do you mean IP code? Is it for intellectual property? So
I think he
that's
meant address IP by that.
so yeah, it really depends on the context. If the application doesn't need to be exposed to the outside world, it's all private networks, and you have ways to work with the infra team to make it available from the inside. And third thing, there are a lot of documentation regarding best practices when it comes to creating images and writing the Docker file in a way where you don't run as a root user, and there are other best practices regarding security. And on top of that, you add the scanning tools that are also helpful when it comes to detecting issues that exist inside the image that might cause some problems down the road. So you have the mix of all of these tools to limit these things.
Good. I'll add on the Slack channel like Stephen did. I'll add on the discussion. I'll add the link to our Slack channel, so the Slack of the community, in case you guys want to reach out or see what people are saying. Thank you all for joining. I want to thank again Women in AI and Becks for her help on this event and the content. Thank you, Asim, as well, and thank you, Eric. And I wish everybody like a great end of the day, wherever you are. Thank you, everyone.
Thank you, guys. Have a good one.
The YouTube channel. Let me add it now. YouTube. There we go. Perfect. The YouTube channel link is on the chat. Thank you. Have a nice day. Bye-bye, everyone. Thanks. Thank you, Asim. Take care.
Thank you.
Bye.
Bye-bye.